everyone. In today's video, we are going to discuss another brain teaser. So the brain teaser is related to the Bayes rule. So let's get started. The question is, consider that we have a bucket. Filled with 3 cards, and those 3 cards have 2 sides. So I'm going to draw it in this way, like dividing these 3 cards into 2 so that the 2 sides are visible, but consider that it has 2 sides with 2 different colors. So the colors are, in this first card, both sides are blue, and the second card only one side is blue, and also the other side is red, and the third card, both sides are red. So the question is, we are going to randomly draw a card. And the card we choose, we observe that one side is red, and the question is, we are asking that what is the probability of other side is also red. So let me repeat the question. We have a bucket with 3 different cards having 2 sides with 2 different colors. First card, both sides are blue. Second card, one side is blue and the other side is red. And the third class, both sides are red. If we draw a card randomly from this bucket and we observe that one side is red, and the question is, what is the probability that the other side is also red? Okay, so these are the details that we have. Let's do the math. So first, let me define an event Bi as the event that represent the number of blue sides in each card. So that we are going to label the cards based on number of blue sides. For example, Bi can be 0, 1. So in Bi, I can be 0, 1 and 2. It means, for example, B0 means 0 blue sides. B1 means 1 blue side and other side is red. B2 means 2 blue sides. If I am going to label it here, we can see that B2, B1 and B0. And I'm going to define the next event as R, which represent the event of observed side is red. Okay, the question we have is, what is the probability of observed side is red and also the other side is also red? It means 0 blue sides. This is what we want to find. So to this end, let's recall the Bayes rule. So I'm going to write it here. Then next page. The general form of the Bayes rule. Let's take the probability of B given A. We write it using the joint distribution and the evidence. Furthermore, we simplify this using likelihood and prior. So this is we called as the prior, and this term we call as the likelihood, and then the denominator we write the evidence using the law of total probability. It should be for all A's, probability of B given A and PA. So this is called as the evidence, and so this is the idea of the Bayes rule. So now let's go to our problem. What we want to find is this one, probability of B naught given R. So let's write it using the Bayes rule. It means, let's go to the definition. It should be probability of B naught, A given B naught, times the prior over the total probability of all the variables across B, like all the cases where event B occurs. It should be PA given B naught or PB naught plus PA B1 by PB1 plus PA given B2. Okay, now let's plug the numbers. Let's take probability of B naught given probability of A given B naught. It means knowing that there are no blue sides, zero blue sides, one side becoming red. What is that probability? Let's go to our picture. Given that there are zero blue sides, it means no blue sides and one side becomes red. So these are the two, there's only one here, right? We can see from these three, cards, this one, given that B naught, so we are in here, and the probability of one side become red is 1. There's no any other choices. So the first term becomes 1 by the prior probability of B naught event. B naught means this one we have three different values for B. So probability of B naught is, it is 1 over third. We assume they are equally likely, these three cards. It becomes 1 over 3. So now it's easy. So we have that term in the denominator. We have that term 1 over 3 plus, what is the next one? Probability of B1, probability of A. So, I think I missed it. This should be all reds. A's should be reds. They should be red. Okay, now it's clear. Now it's clear. So, okay, the second term of the denominator, we are going to write it down next. So, what we want to find is probability of red given B1. So, let's go to here. Knowing that one side is, so let's say, what is the probability of having one side blue, having red, knowing one side is blue? Let's find the cards that have one sides are blue. So we have two choices, right? These two cards, at least one side is blue, right? And the probability of knowing one side blue and becoming the other side red is 1/2. It is this card. So let's go down and plug it here. 1/2 times probability of B1. It means with all three classes, there's only one class having only one blue side. So it is 1/3. And the next one is probability of having one side red while the two sides are blue. We cannot happen that, right? While the two sides are blue, probability of having one side red, having two sides blue means this is only this card. And probability for the other sides become red, it should be 0 because there's no three side. And then comes the probability of B2 as this 1/3. So the answer is, we can see that this goes to 0 and yes, so it goes to 0 all the 1/3 terms are cancelling out. What is left? Let's multiply both numerator and denominator by 2 and we're going to end it up in this value. Okay, this is our final answer. Knowing one side as red, the probability of becoming other sides red is 1/3. So this is, 2/3. Okay, so this is the end of the question. And just to recall, what we try to do is we try to understand the problem mathematically using the notations so that it is easy for us to plug into the Bayes rule. So then we recall the Bayes rule because it is the theory that we have to use in order to solve these types of questions. Having one information, having one observation, we are going to find the probability of the other event. So Bayes rule is often used in these types of questions. So then we plug the numbers, examining the problem, and we finally found the answer. So yeah, this is the end of the session. So if you have any questions or any unclear point, just comment below. So thank you for listening.